Hey guys, welcome to System Design Fight Club. I'm continuing my coverage of Alex Shu's upcoming book on machine learning system design, going off of just the titles that he posted on in a little update somewhere. So I don't have a copy of his approach to this problem. I'm just kind of doing my own coverage and see how it lines up. So this is for chapter 4 of the upcoming book. It is the YouTube video search chapter. And I'm going off just the title of the chapter. I haven't seen anything else in it. The resources that I've used for coming up with the design are a couple of pages on Wikipedia I've been using for a lot of the other problems. Some of the similar problems for this is so I already did the video recommendation video, which has this kind of a similar pattern. This one is actually kind of like that. It's kind of like the video recommendation problem is this one, but spicier, because this one does not use a model for the first part of the way the recommendation service works. But this one, so this one only has like one data model. Well, that one had two data models on it. And then for the ad click prediction video, I had similarly done content-based filtering, which is the approach that I'm going to use for the data model in this one. And then that one also showed how to separate the OLTP and OLAP databases for the feature stores. I've also already made videos a while ago for how to do YouTube and how to do web crawler. There's a little bit of stuff kind of stapled to this that is, I'm going to do a simplified view of that part for the video ingestion. And then if you want to see a more expanded view of that part, you can go check those videos out. And then in my personalized newsfeed video, I had a discussion of text data. So I'm imagining that the data used for search is going to come off the video descriptions and title. As a YouTuber, I'm familiar with YouTube telling me that the title and descriptions matter for how your video is going to like rank on search. And they've been saying that tags don't actually do anything. But anyways, there's some text data, which means that you're going to have to do some stuff similarly to newsfeed, where you do TF, IDF, stop words. Oh, there's actually stimming is another thing for that. I have no idea how I forgot that. That's kind of important as well. So there's a TF, IDF, term frequency, inverse document frequency, which is the word strength. Stemming, stop words, PCA for dimensionality reduction, which you always need to do if there's a ton of words involved. And then also I did content-based filtering, which I'm also going to do in this video. The requirements are that, well, most importantly, users can search for videos. That's kind of super important. Users can upload videos, and then users will have data collected while watching the videos. So it will know what you've watched and not. So it is collecting data on you. TikTok actually in particular does some interesting data collection where they actually watch how much of a video you've sat through. And so then if you've only watched a few seconds versus the whole thing, that is also used. You do not have to like explicitly hit the like button on a video in order for TikTok to suggest more similar content. I don't know. YouTube might be doing stuff like that too, but yeah. I'm just going to kind of generalize it to your completed videos and your liked videos, I think. Some call outs. It looks like another opportunity for applying reinforcement learning in this problem. There's a cold start problem for new users, and actually for the cold start page in Wikipedia, there's an explicit section for new users. So cold start seems particularly relevant there for that case. And so it's an opportunity for reinforcement learning, but also there's the explore exploit problem. So like when you're going through the search results, it's probably going to prioritize videos from channels that you're subscribed to or that you've watched videos from before. And so then the explore exploit problem is for the exploit side of things, you could just only show videos from those channels. And then they're not able to see the ones from places that they haven't watched before versus explore, which is where you don't even apply the personalization at all. So for exploit, it's applying personalization, while explore is allowing them to find new things that they might potentially like. And so this is also something where reinforcement learning or the multi-arm bandit might apply. All right, moving on to the actual data model. So step one is going to be just the model applying something kind of like PageRank. PageRank is actually for graph. It actually works on a graph data model. It's like it leverages a graph DB, and then it uses something called Pregel, which there's a white paper on. Yeah, well, so it's not actually going to run PageRank. And then for step two, the model applies ranking of those results. So first, it just retrieves those results that it thinks are relevant, and then two is applying personalization. I'm going to note the thing there. So PageRank actually uses a graph DB, but there's no interconnecting web pages. So it's the links between the web pages that are leveraged for PageRank. And then they have so also there's this thing called Pregel, which is specific to graph DBs. So I just want to make sure that content's in there. So this is not going to run PageRank, but it's similar. It's going to use a inverted index. So this will actually just use a inverted index. There we go. Let's put the personalization, no personalization on there. And then you finally have personalization applied in step two. So for the data model, there was a lot of stuff I kind of went through to try and make sure I got it right. I was actually really stuck between user-based collaborative filtering versus a content-based approach. Item-based was a pretty obvious thing to just totally remove. Because with item-based collaborative filtering, it's not personalized. It scales really well, and so this is what's used on Amazon.com for recommending similar items or products. So you like select one product, and then it shows you products that are similar. So those are actually like not personalized at all. It doesn't actually take into account like your own user account. On the homepage, it might do that. On the homepage, it'll probably do a user-based collaborative filtering on Amazon.com, but on the product pages, it's probably not personalized. At least that's what I've read on Wikipedia. And then so user-based is maybe you'd end up doing KNN. I don't think that scales super well. User-based, so that's why item-based collaborative filtering became widely popular, is that it's scaled better than user-based. And then so like you might have to do KNN for the classification algorithm. And I don't think that performs particularly well. So that's one of the trade-offs. It doesn't perform well in terms of like runtime. It's slow. And then also it might not have, that would also be more of a 0-1 binary thing, as opposed to what you can get with a linear regression. And like if you're going to do classifier and you're going to do user-based, I think it kind of has to be KNN neighbor-based. So that's alternative to this, which is matrix factorization is a memory-based approach, while for neighbor-based, that is what is it? KNN. So I'm assuming like that's my knowledge of how you would go about it with a user-based approach, but like I said, scales poorly, and this gets a binary output, so not good. And then so I was considering matrix factorization, which is actually very relevant for chapter 6, which was for video recommendation just on the homepage. So it seems that was something that I was considering here, but I was like, well, that seems like a very obvious approach for chapter 6. So why would you even include this chapter as well if it's going to be covered in chapter 6? It'd be like you have two very, very similar chapters that are both doing matrix factorization. And so that's actually how I ruled that out. But I'll split between user-based matrix factorization and content-based filtering. And so when I went with that one, it was I could see how it worked pretty well. And then you would use a linear logistic regression, linear or logistic regression. I think logistic is usually what you're going to use. So that logistic regression would get you more of a what is it, a gradual type of output rather than a 0-1 switch. I should probably specify that. So with KNN and gradient boosting machines, I covered that too. So gradient boosting machines was like kind of, this one's really popular for it's when you're doing classification in general, for a lot of things where you're just trying to do an on-off yes or no output, gradient boosting machines are super popular. You'll usually start with a random forest. And then when you're like just to kind of like try things out and experiment with data models and what you want to do and what kind of results you can get out of it, you'll start with like random forest, then you'll switch over to gradient boosting machine. Like that, so that one requires a grid search approach of tuning a bunch of parameters. And so that's why you don't want to start with it, is that it requires a crap load of parameter tuning. But these have more of an yes, no, or binary result, while for regression, you get a gradual, smoother result returned by it. And so that's why, so that was another reason why for neighbor-based, you're kind of like glued to using KNN from what I can understand. And so with user-based collaborative filtering, you can't really do regression as much is my takeaway. So that kind of helped rule that one out as well. Yeah, so I landed on content-based filtering for that approach with a logistic regression, and that's my reasoning for it. This is a machine learning book, so I think a lot of care needs to be spent on the data model, and I have definitely given it my best. I think we're ready to move on to the diagrams now, though. Okay, so we're going to have 3 use cases. So there's going to be the video upload one, and we're going to have the, come on, right. There's 2, there's 3. So there is video upload, and you have the search, and then you have data collection while you're watching. See here, user uploading video. And here you have user searching for video. Okay, and then here you're gonna have users watching a video. There we go. And we're going to cover this one later because that's just me going super deep. I can't imagine that Alex is going to show that part as much. We want to focus on this one in particular. So let's go ahead and slap some back end services on there. This one will be the video recommendation service or video search service. And then here we're going to have video data collection service, which is just going to happen as you click on videos or as you're watching them. Let's talk about the data kind of getting passed into these. So here you're going to have a user ID. That's all you're going to get. And then here you're going to have a user ID and a video ID. Okay, and this one's just going to return a 200 response. Let's maybe hold off on, you know, I can draw the responses for now, and then I'm just not going to connect them until we get that far into the request response flows. Over here, we're going to get ranked videos. Yeah. Cool. All right. And we're gonna need to have we're gonna have a candidate generation service, and we're gonna have a ranking service. Similarly to the chapter 6, but this one's just less spicy. This one is the there. Okay. So I'm going to fill out more of the search side, and then I'll go into the video data collection service, and then we can talk about the uploading video, which is going to get some of the data into a different part of our data warehouse. All right. And a search. Oh, that's right. You're also going to have the search query. Okay, and then you're going to send it off to the candidate generation service. Then the candidate generation service is going to, it's just going to use an inverted index. And so we are going to have it's the search results, EBs, something like Elastic search, possibly. Okay, this is going to be, I'm using similar naming convention to how I did this in the YouTube video. I think I might have just called it search results DB over there as well. So you have your search query. It's going to, something has to like turn the search query into proper semantics. So we can pretend like the search query is just something like, we'll say they're just looking up like system design. That's it. Just their search query is just that. So something's going to convert it into a proper thing to check against the inverted index. Then we're going to send the search query over there. Actually, I think we don't even need the user ID since we're not doing any kind of personalization here. Yeah, we don't actually need any user ID stuff there. Our search query, and now we're going to do the inverted index. We'll get a list of video IDs back. Okay, so we got our list of video IDs. Actually, it should check a cache first. You know what? I'll come back to that later. I was thinking ahead to the user uploading video and how the YouTube design kind of worked. Yeah, we can come back to this later. The cache is like not really, it's like a gritty detail that like is probably going to get left out. Okay, now we forward that over to here. Okay, now we got our list of video IDs, and we can now do our ranking. So we've got the ranking service. We want to personalize our results. We're doing the personalization step. So we're going to have those video IDs, and we're also going to pass in the user ID. Okay, and so now this is where we would have our data model. But I'm doing content-based filtering, which is from what I've read, you have like a model trained to each individual user. So you're gonna have a model object, a model store. So we're gonna have our model store, which is going to store individually trained data models. So it is a object store like S3. It's a great way to do that. Given the user ID, you're going to figure out what data model you want. So it's going to come over here with the user ID. And then you're going to get specific data model that you want back. So user specific data model. Okay, was there anything? Oh, you needed to flatten it. So, right, I was annoyed that some of the resources I was looking through, I also like tried, other areas of the internet, they were like not solid. Wouldn't recommend them. Uh, so nothing really was specifying the inputs and outputs of the data model when it's running in production. And so I wanted to like definitely give it my best shot to actually do that. So we're going to have video feature vals, video feature values. So you're going to have that video ID and you're going to turn it into feature values that are going to be the actual, which are like aspects of that specific video. In order to get those, you're going to have a video feature store. And so we're going to also put that up here. Video feature store. A lot of these feature stores are a KV store, some kind of key value store, where you're just going to give it the user ID and you immediately get back this blob. DynamoDB probably works. Redis, perhaps. Yeah, Reddit. Well, so yeah, I mean, you're going to have hot videos too. Yeah, all right, whatever. Okay, so you're going to have the video ID that you pass in. And pass in a video ID, and you're going to get back the video's feature values. We're going to talk about how you're going to get the data into there later in the video, of course. You're probably not going to have a lot of other content that talks about how the data actually gets into the feature store. I couldn't find a whole lot, but I know how it works. Okay, so you do a request of the video ID and you get back the video feature vals and you're going to plug those into the data model. And then as output, you're going to get the video score because we're going to do logistic regression. So it's the video score. And then I'm going to put that at bottom below our data model, logistic regression. Let's give ourselves a little bit more space. That. Then over here, there we go. Input, output. And so then we're going to have a video score for each of the videos, and then you can have them sorted and you can have a threshold cutoff, or you can just return the top 10, and those are going to be out of here. So you have your videos sorted by rank, possibly filtered to some threshold, or just cut off to something like the top 5, or I think it's like 20 videos per page. So we could say something like that. or some of that filtering might happen on the video search service. I have no idea which one determines how much to apply that personalization. Again, that's the explore exploit problem. Okay, videos sorted by rank, and then we're going to return those ranked relevant videos to the user over here. Okay, very cool. What do I want to do next? Got the video feature store. I've got the model object store. Let's maybe talk a little bit more about model training and specify that a little bit more. This is probably where a lot of content out there is just going to stop with this problem. Is just that, just the diagram that I have over here is probably all you're going to see most of the time. I want to go a lot deeper than that, though. I really want to go a lot deeper than that. It's going to have the model training workers that are going to spit out your trained models. Okay, and let's maybe start, oh, the video feature store is also going to, it's going to pull in data from the video feature store, but that is the non-target data. You need a target class. You have to be, for a classifier when you're training it, you're trying to get it to predict something, and the predicted value when you're training it is not off of any of the stuff that we're going to be pulling off of here. Want to predict a yes, no, are they going to watch it? And we're going to get that data from over here, which is our segue into filling this one out a little bit more. Okay, so we have the user ID and the video ID into our video data collection stuff, and then we're going to have the user watch history. We'll call this the user watch history. And this is going to be the OLTP database, just, live prod, send that thing in. You make a request like, hey, here's my data. It just happens like when you click like or silently in the background asynchronously as you're watching, feeding data over here. And then you put it into the database. The database is like, yep, I've got it. They're watching that video. I hear you. And then you return back your 200 success, which is over here. Now I can finally complete this little cycle. Very cool. All right, and then asynchronously, this is going to get copied into our data warehouse, as I've done in so many of my other videos. So there's our OLAP clone. And we're going to do change data capture with a DB trigger. There's a variety of approaches to change data capture, but this is not the video for that, not the series for that. Okay, and so we've got that. And so it has to be in an analytical store because we are going to do this big full table scan or something. We're doing an ETL. We're doing ETL. That's what's going on here, is we are doing ETL. And that's really expensive. It's really hard on the database. It adds a lot of overhead to what's going on. And so that is why we can't do that in OLTP and why we have these DB triggers going on. And then this is also going to provide the targeted data. This is the thing that we're trying to predict. Are they going to watch it or not? So let's explain that. This is the target data, target class. So you're doing a classifier, you're trying to predict the class. Yeah. So then this is going to be data other than the targets class data. And this is what you're going to use for basing your predictions off of. Okay. So if you're, well, so again, OLTP, OLAP split, perhaps the OLTP one will be Redis, but for the OLAP one, you can't do a KV store. you can't do a KV store for your OLAP one. You of course need to be able to do like a current query or something. So yeah, it would not be you'd have to do the split like I mentioned is in one of my other videos. The which one covered that split? This one, ad click prediction. Yeah, that's where I covered that split. Okay, so we got our trained workers. Oh, I wanted to do the table thing. That's right, the how the video store looks. So the rows are going to be video IDs, and the columns are going to be video features. Okay, and I'll get into the feature engineering here in a minute. This is good. This is another good checkpoint where I can zoom out and think for a minute. This is another piece of great progress on how far we've made. What did I want to do next? Yeah, we can talk about the feature extractor workers. Yeah, so we're going to want to get this data from somewhere. We have to do the feature shaping, the feature engineering. We're going to do some kind of feature engineering to get it to look like that. So that's going to have to come from somewhere, and we're going to need to do, we're going to have, nope, not that one. Whoops. We're going to have some feature extractor workers. Or they're just task runners. I don't know. But we're going to have to do some kind of feature engineering in order to get it into features that in order to get it more into a more optimized format for the data model to run against. So those are going to come from somewhere. So in our YouTube video, we had a video metadata DB. Let's go ahead and draw that on there. That's going to be where our data comes from. Video metadata DB. There we go. Actually, I should draw it like this because it's the task, it's the workers that are making the request. There we go. All right. Yeah, you know what? I'll call it a day. That's fine. I'm going to draw that. So we have the video metadata DB, and then we also, oh, right. So this is where you're going to have the TF IDF work. It's where you're going to do stuff like that. So that is the stimming, the stop words, the dimensionality reduction. This is where that's going to happen. Okay, I just need to fidget like a little bit more with this. Sorry, guys. There, I'm happy with how that looks now. So you're going to pull that off. Where does that come from? Let's go ahead and maybe connect our diagram over here a little bit. I'm going to do a very simplified view of how the YouTube upload works. I think in that video, I called it the video capture service on my diagram. And then I'm going to, yeah, I'm just going to have these. So this is, you're going to be uploading your video to there. It's just a whole video file. So we're going to say video file. That's obviously not, well, actually, this is for, you can have the video file and metadata about the video. So that would be title, description. There we go. And then we're going to send just that latter half you obviously don't upload the video file directly to the video capture service. This is a simplified view of that. And have just the metadata about the video getting forwarded over there. I'm going to like really flag simplified view. Nobody really covers, nobody's going to cover this part. I'll put like a box around which part is simplified. It's like right around here. This is all a simplified view. Okay, you got the video capture service, the video metadata DB, the PageRank workers. You're going to have to fill this out. This is going to get filled out. So you have this, which is not necessarily optimized for your search results database. So you're going to have kind of like PageRank workers. We're going to call it that. It's not actually what it's running there, but it communicates the concept really well. That's why I keep doing is that's why I keep saying that, even though that's not what happens, is that it just communicates the concept really well. Let's give ourselves some more space. Okay, and then we have our PageRank workers. They are going to pull some data from here, like this. And they're going to write it over to the search results. I'm going to do that. That is within our simplified view of things. And then I really wanted to have a cache as well. Keep it realistic is that you also have the search results cache possibly, or like really popular queries. You could use something like Redis. And so before you check this one, you would actually try and do a check against Redis, which will have a much cheaper and well, at least faster. It'll at least be faster. Is that you are first going to try your search query here. You're going to hope that it returns a list of videos. Those are documents for inverted index. When you're building the inverted index, it's mapping from terms to what you call documents. Anyways, you're first going to try this, and then if it's empty, then you go ahead and call Elasticsearch, which is going to be a little bit slower. It might do scatter gather. It might be a bad time. It might be a little bit slower. And users hate latency. There's that 3-second rule of thumb for users clicking away from a web page. Okay, so again, that is a simplified view. What else did I want on this side? Now, we explained how the feature extractor workers get their stuff. It's from that. And again, this is LTP OLAP separation. You would need that. Simplified view, though. There we go. Okay. What else did I want? Should I cover everything? Oh, let's try out reinforcement learning. Yeah, I'm going to take a shot at this. This is going to look ugly, but I just really want to have, like, I'm really hoping that AlexShoe has an applied example of, actually, let's do a copy paste for my guys in the Discord channel, so we can see it before I do this whole thing and after. And I'm not going to copy all the nitty-gritty details that I'm sure nobody else is going to cover in order to keep this second diagram simplified. And we can even go ahead and delete that cache since it is a nitty-gritty detail. And we can go ahead and delete this because I have it on the first diagram. And let's maybe give ourselves some space for how I'm going to do this with the reinforcement learning. Okay. So we are actually going to have a stream of this stuff. we're actually going to go ahead and do a stream of your video watching stuff so that it can react in real time. We want real time. So this is all a big offline process. We'll call this the offline route. And we want the online route. So we'll have this like that. And then, so we have the Kafka stream. You would still have to do some kind of normalization, I think. You might still have to do something to, you would have to, so it's video data. So you have the kind of data that you have here is what videos and what user. Okay, so you might have to normalize that. And so you're going to have this. Let's not talk about the normalization first, though. So you're going to feed this data in real time through a through your reinforcement learning model, your reinforcement model in real time. And then somehow it is going to be plugged into the ranking service. I don't know if you host it directly. So our content-based approach does not directly host the model on the ranking service, but somehow it's going to be invoked by the ranking service. I don't know how. That's like my biggest mystery here is like, how do you? I've never heard of. I don't know how to. I don't even have toy problems for how to do reinforcement learning. That's why it's so hard. I haven't even seen toy problems for reinforcement learning. I've covered classification and clustering a ton on my own. I've even handled text data on my own. I haven't done reinforcement learning. That's what's so tricky. I have no idea how to host it. So we have this, and you're going to need to feed video features. You want the video features, and so that's why we're going to want to do, where is this? Yeah, nope, not that one. We want the feature extractor workers. Well, so it's whatever turns it into the video feature store. Oh, I didn't do the video feature store. I didn't show how to hook it up to that. Yeah, shoot, hold on. No, I did. Yeah, I did. Video metadata DB over to the video feature store. That is where it comes from. So we're going to use the exact same logic that normalizes it over there. So I'm going to copy this. Then I'm going to paste it over here. And so this one is going to take a copy of it. Yeah, this one's going to have a little copy of it. So this is the what I had drawn so far was the high level view of how you're going to feed data into the model. But in reality, it's probably going to go through a feature extractor worker. So now we can go ahead and delete this. We're going to feed it directly into the data model. And so this can be Lambda triggers is what you have in AWS is Lambda triggers running feature extractor workers. Let's go ahead and say all that. And so workers is not actually the right word here. It is actually going to be full-blown, well, not full, I don't know why I said it like that. It's they're task runners is a more accurate term for what's going on here than workers. Workers implies a big batch processing job, and that's not what's going on here. So we have that. We're somehow going, it's somehow going to get fed into, it's going to call data model in order to train it. So that's why this is so ambiguous, is like it's not going to call the ranking service. It's going to somehow feed data into the data model to train it. But like, I don't know how it's hosted. I don't know if it's directly on the service. That would be weird. So that is the offline model that's trained, and then this is the online model that's trained. And we can label those. How do I want to do this? We're going to stretch this one over a little bit more. I'm going to go ahead and bring back that dashed line. Oh, and then I also forgot to do this, is that this is also going to get fed directly off of that. So you have two paths coming off of, you have two paths coming out of that stream. This kind of reminds me of the reconciliation thing from the ad click aggregator. It reminds me of that, is that you have there's this, going to make that dashed. Let's maybe make this a little bit more narrow, move it over to give it more room. But it's just, the dash line is just representation of this little route. And let's call this the online process. It's going to say online process as opposed to the offline process. In my video recommendation video, I think I talked about Netflix. And if you dig into the documentation on matrix factorization and what Netflix is doing, you're going to see those terms come up of online versus offline. And I think they even have a nearline process. They have a nearline incremental thing as opposed to online. I've never heard of nearline before, but they even get a little bit more sophisticated. And that's where these terms come from, is online versus offline. And it reminds me of the ad click aggregator thing. The online process, I heard for reinforcement learning, it can have this issue called catastrophic forgetting. And so similarly to how ad click aggregator has that slow route and the fast route, and you need to do reconciliation, is that it's because the fast route, the online process, has issues that can happen, and it can lead to discrepancies. And so the online process can have errors, but it's a lot more fast reacting. And in particular for like a platform like TikTok, you know, you might be in like the mood for like certain videos on specific topics. Like, let's say I'm on a system design video watching binge or something. And so then it'll recommend that in my homepage feed, as opposed to if I'm in the mood for movie clips or something. There's a bunch of movie clip channels that I've seen, or if there's anime clips or something like that. And then it's like, oh, he's in the mood for anime instead now. Let's show a bunch of anime clips in his homepage. And so it does that reaction to like what kind of subject or like mood of videos that you're in through this online process. And it's picking up on what your current what's the word? Phase is. Like you might go on like a binge of watching specific movies, and that's how it does that reactive fast reaction thing, is the online process. Okay, I've probably bored you enough with that. Yeah, so that's my stab at reinforcement learning on it. I think I have everything I want now. That. Right. The cache. Yeah. Yeah, I think I've got everything. Okay. Thanks for watching. This has probably been a longer video, and I definitely did not have my stuff together for the reinforcement learning part. That's probably going to have really low user attention on this video. But I really hope that Alex Chu's book is going to actually cover reinforcement learning somewhere. Otherwise, I'm going to have exclusive content on the internet that actually covers that, which would be shocking. yeah, I really hope the book covers applied reinforcement learning somewhere. Thanks again for watching. Yeah, I'll let you guys go. See you next time. Thanks.